Okay guys, so let's begin. We start off by open the player scene and let's head into mesh instance, and under material here is where we will add all the materials. But to be able to know what material to add on what surface, we can expand this, the mesh, and you can have a look here at the surface under the mesh, because here it says name wood, name fabric, name wood, and so on. So this just makes it easy for us to know that, yeah, surface 0, or rather the 0th index here, has the name, it will be the wood, and so on. So under assets, let's create a new scene, not a scene, new folder called materials. And let's create a couple of new materials. So new resource, spatial material. And this will be wood, ship, wood, material, save it. And let's change the color to brownish. Alright, and save it. And once again, mesh instance. So surface 0, this is the index 0 here, we'll have the wood. And we also have the wood at surface 3, which is the second index. And this also goes for surface 5, which is 4. And this also goes for 7, which is 6. And let's see, so we have dark wood, light wood, dark red, and wood, so the last index as well. Let's create a dark wood material. New resource, spatial material, ship, dark wood, dot material, save it, and let's choose a darker brown, and save. Mesh instance, so dark wood was surface 9, that is index 8. Perfect. And then we have a fabric as well, so new resource, spatial material, ship fabric, material as well. Open up this, albedo. Let's choose what fabric color you want. I'll go with let's go with a pinkish. Save it. Mesh instance, so 2, 4, 6, 8. 2, 4, 6, 8. That will be 1, 3, 5, and 8, which is 7, right? I'm right? Yeah, I think. Yeah. Okay, and 9 will be a. Let's see. So 9, which is 10 here, light wood and dark red. So light wood. Let's create a new spatial material. Ship light wood dot material. Whoops. Misspell that. Material. Open this up. So we have a light wood. That will be something like somewhere around that color. I don't even know. Let's just attach it, and you know what? I couldn't care less. So this dark red will also be a light wood. Yeah, you can choose to change this. So here the player ship is, and let's see how it looks. It looks awesome, cool. Okay, so now to the water. We will start off by selecting the mesh instance and rename this to water. And we will also remove the material, and we will change the size to, let's say, 200 and 200. And we also need to subdivide the width and depth with, let's say, 300 and 300. And this will give us these polygons here. So let's say you can change this value to, let's say, 200 and 200 to get bigger polygons on the water. But I think that subdivided with 400 and 400 gives us a pretty good looking polygon water later on. So let's just save this, and under material create a new shader material and expand this and create a new shader. Okay, so first thing first, disclaimer, this will not be an in-depth tutorial on how to write shaders, because I'm not that experienced myself. I'll just show you guys how I create this water. And this is once again inspired by thin matrix tutorials and another guy called Bastian Ollage, so big props to those guys. Anyways, so we'll start off by declare what type this shader should be, and this is a shader type spatial. Simple as that. And we will we'll call a function, we'll create a function called vertex. So this function acts upon each vertex on the mesh. So each vertex goes through this function rather, and we'll create another function called void apply distortion. Whoops, and this takes in a vec3 vertex and a float time. So on the vertex we will set the vertex to be apply distortion. We'll pass in the vertex, we'll pass in a time times 0.1. So the vertex is the current vertex that the shader is working on, and the time is another variable that exists within the shader language, Godot's shader language, that is. And we just multiply it with 0.1. Okay, so this actually needs to be a vec3, not void. My bad. Anyways, we will create another function called float generate offset, and this takes some parameters as well. This takes a vec3 vertex, it takes a float val1 and float val2 and a time as well. And we'll create a speed here, a variable called speed that is set to 0.1. This we could actually set as a uniform variable, so we can modify this from the editor, and I think we'll actually do that as well. So let's do that. So uniform float speed equals 1.0. We can set the range, hint range 0.5 to let's say 3.0. I don't even know. We will declare some variables. So x will be vertex.x, float y will be vertex.y, and float z will be vertex.z. And after that I will copy and paste some stuffs. So here we do have some variables that is given some random values. So these are just taken from thin matrix actually. I think I tweaked them a little bit, I'm not even sure. Anyways, just write this down, and once you have done that, you can tweak this. You see, we will create this amount variable soon. But you can try to just, you know, divide the amount variable with 2 there, and just multiply this with another time, and so on. So you can tweak this and see if you can get some nice results. But we will create this uniform variable called float amount. That'll be hint range. Let's say we can have it between 0.05 and 4.0, and we'll initialize it with 0.2. So the uniform variables, this just makes sure that they gets exposed to the editor, so we can change them from within the editor, as you will see later on. And once we have done that, we can return the amount times 0.5 times sinus radians z plus cosinus radian x and plus cosinus radian y. And that is that for generate offset. So in the apply distortion function, we can create three new variables called xt equals generate offset, and we give it the vertex and we give it the time. And between those two we also need to give them some hard-coded values. You can once again just try to play around with these values. Change this to 0.4 or 5 or whatever and see how they differ. And for the yd, we'll provide the vertex, we give it a value of 0.1 and 0.3, and for zd we'll give it the value of 1.15 and 1.2, and we'll return the vertex plus a new vec3 with the newly created variables. So that is that, and look at this. Look at this, guys. Have you ever seen anything prettier than these vertices just moving around in a wavy form? If we choose to have a display normal here, you can't see anything because we don't have any normal set or anything on the on the mesh. So that is something that we will do now. And this is done by calling another function, or rather overriding a function called void fragment, and this function acts upon each pixel on the screen to tell what color and so on each pixel will have. So we'll just call a normal. Once again, this is a built-in variable. Normal. This is a can we see what type is it? Yeah, this must be a, yeah, it's a vector3, of course. So we'll call normalize the cross product between df x vertex and a df y vertex so that calculates a normal. And you know what, we can actually set the albedo color as well. Albedo to be an out color, red, green and blue. And the out color will be a uniform variable as well that we will declare up here. So uniform vec4 out color will be a hint color vec4 0.0, 0.2, 1.0 and 1.1, sorry. Okay, so if we look at this now, the water got blue, and that is awesome. So as you can see, if we expand the shader and we have this shader parameters, we can change the speed of the variable of the water, and we can change the amount, so how crazy the water will be, and we can also change the color. And if I now go to a normal perspective, you can see we do have some shades in the water as well, because we calculated the normal values. But we are not done here. Head back into the script, the shader, and now we will give the water some transparency, and this will actually be implemented in a way that whoops, I messed up. Okay, so we will actually use a pretty cool technique that Bastian Olich actually made a tutorial on, and that just gives the water a more realistic transparency than just to provide the water with a simple alpha channel. So this is done by creating a new variable called float depth of the texture. We'll give it a depth texture and screen UV as well, and we get red value. We make the we set the depth value to be a value between -1 and 1, and we'll call a new function, and here is where this Bastian Olic, where he got me lost. This is just some beautiful kindergarten math, right? Okay, so just copy this line down. I have no idea what it does, but anyways, once this is done, just call depth, and we'll just add it with vertex.sed. Then we set the depth to be exponential, negative depth times beer factor, and this is a variable that we will be creating. Once again, a uniform variable. Hint range between maybe, let's say, 0.1 to 20.0, and we'll start off by giving it initial value of 0.1. Okay, and finally we'll set the alpha channel to be the depth clamped. So we'll clamp it 0.1 minus depth. We'll clamp it between 0.0 and 1.0. And that is that. So if we now take our player and just lower this guy down in the water, hopefully, yeah, as you can see, he gets, you can still see him once he's down in the water. But if we do, okay, we need to adjust the, we need to change the beer factor a little bit. So let's increase the beer factor to around, let's say 9. Save it. Player, lower the player down in the water. Okay, 9 was a bit too much, so let's lower it down to 3 maybe. 3 too much as well. I don't even know. Yeah, maybe it is. Let's set that to 1 then. Okay, anyways, let's leave it at 1 for now. So if we lower this guy down in water, if I look at him from the top, we still see him pretty good. We can lower the whole boat down, so we can still see the boat. But if we give it a slightly angle, the boat disappears. So this is pretty realistic to be, because the further down in the water you get, the less visible objects are. So one final thing, we will make the boat. We'll make the boat modify the water, rather interact with the water. And this can be achieved by heading into the shader again. We'll change the color of this water, something round this color, a little bit more tropical. And on the vertex here, in the vertex function, we'll create a new variable called world position, and this will be the world position in the game. So vec4 vertex 1.0, and we get the x, y, and z. And we need to create a new uniform variable, uniform, and this will be vec3 player position. So we need to keep track, the shader needs to keep track of where the player are in the world. And once we have those two variables, we can get a length between the world position, the current vector's position, vertex position in the world, and the player's position. So this is done by calling ABS and square root. We call world position.x minus player position.x times world position.x minus player position.x, And then we grab this whole section and we then let's see, add, and we set, and we do the same for Z as well. So we just calculate the hypotenuse, right, between two vectors. And if length is, oops, what did I do? Oh yeah, also if length is less than 5.0, for example, once again you can change this value as well. We just set vertex.y and add to it 5.0 minus the length times 0.2. And this just makes the water to rise where the boat is, okay? So, whoops, I did something, right? Head into the shader again. Yeah, something happened. And save it, and grab the player, and increase his position a little bit. Okay, so now when that is done, we need to do one last thing, and we need to tell the shader where the player is. We need to constantly update the player's position to the shader. So let's create a script to the sandbox node, and we'll get a reference to the player. We also get a reference to the water, and we override a process function, and we call water.mesh.material get surface get materials. We get a 0 index on the surface because the water just has one surface. And we call set shader param, and this takes a string of player position, and then we get the global position of the player, and this is done by calling player.global transform.origin. That is that. And also, guys, just make sure that in the player, just change in the camera, just change the offset to 12 here, because that gives us a little bit more vision. And as you can see, the water gets interacted where the player are. I think this looks pretty cool. So anyways, that is it for this episode. So in the next one we will give the scene a world environment and provide some cool and nice looking lights. So anyways, until then, peace out.